Welcome back to week 1 of ma161 Calculus. My name is Götz Pfeiffer and this video is about numbers. Calculus is based on the real number system. This number system is introduced in a step-by-step fashion, starting with the natural numbers 1, 2, 3, 4, 5 and so on, the numbers we use for counting. This set of numbers is usually denoted by a capital N with an extra line through it, as shown here. Next, this set is extended to the set of integers or whole numbers by adding the number 0 and all the negatives of the natural numbers, -1, -2, -3 and so on. The set of integers is denoted by a capital Z. That's because the German word for numbers is Zahlen. Next, we have the rational numbers, denoted by Q. They are constructed as quotients or fractions of integers, meaning any rational number R can be written as m over n, where m is an integer and n is a natural number. In particular, n must not be 0, because, as you know, division by 0 is not allowed. Rational numbers are written in quite a variety of ways. For example, the fraction 1/3 is often written as 0.333 with an ever-repeating sequence of digits 3. Going the other way, a decimal number like 0.17 can be written as a fraction 17 over 100, and most people, like me, I guess, prefer -3 over 7 over the fraction of -3 and 7. Every integer, here like the number 19, is of course a fraction, 19 over 1, but usually you wouldn't write it that way. In this course, when we say number, we mean a real number. The set of real numbers is denoted by capital R, and we will use this notation throughout the course. One way to imagine a real number is as a point of the so-called real number line. That is a geometric notion consisting of a straight line which extends infinitely to the left and infinitely to the right. Choosing some suitable scale, depending on what range of number one would like to display. One then chooses a point on the line, the origin, and that point corresponds to the number 0. From there, a positive number x is then represented as the point at distance x to the right of the origin. Similarly, a negative number, -x, is the point at distance x to the left of the origin O. Some important numbers, like square root of 2 or the circle number pi, cannot be expressed as quotients of integers. These are called irrational numbers. Like the square root of 3 is often approximated by a sequence of digits after the decimal dot. Here it's 1.41421356 ... But the sequence of digits, as indicated here, goes on and on, but it doesn't repeat itself. So we often deal with approximations to real numbers. Rational numbers and whole numbers, in contrast, are absolutely precise. There's no need to approximate them. With real numbers, we often deal with these approximations. That's it for now. The next video will be about set theory.